In the spring of 1900, a group of Greek sponge divers took shelter from a storm near the small island of Antikythera, between Crete and the mainland. When the storm passed, they dove. On the seabed, they found a Roman-era cargo ship, bronze statues, marble sculptures, glassware, coins, and one object that nobody knew what to make of, a corroded lump of bronze, roughly the size of a shoebox. It sat in the National Archaeological Museum in Athens for 2 years before it cracked open and revealed what was inside. Precision bronze gear wheels, interlocking, some no larger than a coin, their teeth filed individually to sub-millimeter tolerances. The scholars who first examined it concluded the object could not be from antiquity. The technology was impossible for the ancient world. It had to be a medieval instrument that ended up in the wrong wreck. It wasn't. The claim, stated carefully, is this: the Antikythera mechanism is not just an impressive ancient artifact, it is evidence of a ceiling, a technical ceiling that ancient Greek civilization reached, and that the civilization that followed it did not. The mechanism encodes differential gearing, precision gear cutting, and a mechanical model of the cosmos sophisticated enough to track the variable speed of the moon across its elliptical orbit, a phenomenon that was not even formally described in Western astronomy until Kepler published his laws of planetary motion 1600 years later. And nothing comparable was built again for roughly 1400 years. The argument that follows from this is not fringe. It is taken seriously by historians of science and technology. If the Greeks built this, if this level of precision mechanical engineering existed in the 1st or 2nd century BC, then what else did they build that didn't survive? Bronze was the most recycled material in antiquity. When an object stopped being useful, it was melted. The Antikythera mechanism survived only because the ship carrying it sank and the seabed preserved it for 2,000 years. Every other object like it, and the mechanism itself implies a workshop tradition that could produce it, was most likely melted down and is gone. The stronger version of the argument reaches further. It asks not just what else the Greeks built, but what the existence of the mechanism implies about the depth of the knowledge tradition behind it. The mechanism is not a prototype. It is not crude. Its gear ratios encode the Saros cycle, the 223-month eclipse predictor known since Babylonian astronomy. It encodes the Metonic cycle, the 19-year synchronization of solar and lunar calendars. It encodes the Callipic cycle, a refinement of the Metonic, and in the front gearing, it models the anomalous motion of the moon using an epicyclic gear arrangement, a pin and slot mechanism that translates a constant rotation into a variable one, matching the actual observed variation in lunar speed to within the precision achievable by naked eye observation. That is not something built on a first attempt. The astronomical knowledge encoded in the mechanism represents generations of careful observation. The mechanical engineering required to build it represents a manufacturing tradition with specialized tools and trained craftsmen. Neither of those things appears in the surviving record before the mechanism itself. Here is the pillar. The Antikythera mechanism is not evidence of a lost civilization or a forgotten technology that the mainstream has suppressed. It is evidence of exactly what historians of ancient Greece have argued for decades, that the Hellenistic period, the 3 centuries between Alexander the Great and the Roman consolidation, was a high water mark of Greek science and engineering that we have substantially underestimated because so little of its material culture survived. The mechanism is anomalous in the archaeological record, but anomalous does not mean impossible. It means we have one example and no others. That is a problem of preservation, not necessarily a problem of history. Derek de Solla Price, the British physicist and historian of science at Yale University, was the first researcher to study the mechanism systematically. His landmark 1974 monograph, Gears from the Greeks, established the object as a genuine ancient Greek astronomical calculator and argued that it fit coherently within the known tradition of Greek mathematical astronomy. Price's view, which has been substantially confirmed and extended by subsequent research, was that the mechanism was not a singular miracle, but the surviving exemplar of a broader tradition of Greek mechanical devices, most of which were lost. The candidate origin for the mechanism is Rhodes. In the 1st and 2nd centuries BC, Rhodes was the center of Greek astronomy and mechanical engineering. Hipparchus, the astronomer who developed the first known model of the lunar anomaly, who cataloged over 800 stars, who calculated the precession of the equinoxes, worked at Rhodes in the 2nd century BC. The historian Cicero wrote, in the 1st century BC, of a device built by Posidonius of Rhodes that showed the motions of the sun, moon, and planets. That device has not survived, but its description matches the function of the Antikythera mechanism closely enough that some researchers have proposed they may be the same type of instrument. The point is this: the mechanism is not without context, it is without surviving peers. That is a different problem, and it is the problem that every critic of the more expansive claims about the mechanism has to grapple with honestly. The serious examination of the Antikythera mechanism began in 2005, when a consortium of researchers used microfocus X-ray computed tomography to image all 82 surviving fragments in 3 dimensions. This was the Antikythera Mechanism Research Project, a collaboration between Cardiff University, the National Archaeological Museum, Hewlett-Packard, and X-Tech Systems. What the scans revealed was more complex than anyone had anticipated. The fragments contain not 30 gears, as had been estimated from surface examination, but at least 30, and the inscriptions on the interior surfaces, now legible for the first time, described mechanisms that had not yet been identified in the physical remains. The back of the device carried 2 large spiral dials, one showing a 19-year Metonic calendar, one showing the 223-month Saros eclipse cycle. The front carried pointers for the sun, moon, and, it appeared, the 5 planets. But the front gearing was largely missing. The fragments that survived gave partial evidence. The inscriptions described planetary displays. The mechanism for producing them could only be reconstructed theoretically. Michael Wright, a former curator of mechanical engineering at the Science Museum in London, spent more than a decade building physical reconstructions of the mechanism. His work, largely self-funded and conducted independently, identified the crucial tooth counts of several gears and demonstrated that the front of the device used a system of concentric rings to display the planetary positions. Wright's reconstruction ran. It worked. It was the first physical model of the complete mechanism ever built. Then in 2021, Professor Tony Freeth of University College London and his UCL Antikythera research team, including David Higgin, Aris Dakanalis, Lindsay MacDonald, Myrto Georgakopoulou, and Adam Wojcik, published a new reconstruction in Scientific Reports. Their model proposed a system of nested concentric tubes carrying the outputs for all 5 planets simultaneously, driven by a series of epicyclic gear trains that encoded the specific astronomical period relations inscribed on the mechanism's surface. The Venus gear train, for example, encoded a 462-year period relation, a cycle that does not appear in any surviving ancient Greek astronomical text. The Saturn gear train encoded a 442-year cycle. Freeth's team had to work backward from the physical constraints of the surviving fragments to determine what gear counts would produce those cycles while fitting into the available space. It is, in Freeth's own words, the first model that conforms to all the physical evidence and matches the descriptions in the scientific inscriptions engraved on the mechanism itself. Now consider what it took to build the original. The gears were cut from bronze sheet by hand, cold forged, sawn, and filed. The largest gear has 223 teeth arranged around a diameter of 14 centimeters. Each tooth is less than 1 millimeter long. The spacing between teeth has to be consistent enough, across all 223 of them, that the gear meshes cleanly with its neighbors across thousands of rotations. This was done without power tools, without precision measurement instruments as we understand them, and without the ability to verify accuracy under magnification. Researchers who have attempted to replicate the gear cutting by hand, using tools and materials available in the ancient world, have found it possible, but demanding a level of craft skill that can only be produced by sustained practice in a dedicated workshop. You do not acquire this skill casually. You acquire it through years of training, in a tradition that teaches it, in an institution that values and funds it. That institution has left almost no trace in the record, which brings us to what the mechanism actually implies. Here is what the record shows and where it ends. The mechanism is real. Its capabilities are established. The UCL reconstruction demonstrates that a device of this complexity could have been built with ancient Greek tools and materials, and that its astronomical content is consistent with the Greek scientific tradition centered at Rhodes in the 2nd and 1st centuries BC. The record also shows the gap. Comparable geared devices do not reappear in the archaeological record until the Islamic world in the 11th century. Mechanical clocks of similar gear complexity do not appear in European cathedrals until the late 13th and 14th centuries. That is a gap of roughly 1,400 years between the Antikythera Mechanism and the next machine of similar mechanical ambition. The mainstream explanation for the gap is not controversial in the history of science. The craftsmen who could build precision-geared devices were few. The knowledge was held in specific workshops, possibly a single lineage of makers. When those workshops were disrupted by war, by conquest, by the shift of patronage from Greek scientific institutions to Roman engineering priorities, or the tradition died. Not because the knowledge was suppressed, because knowledge that lives in skilled hands and is not written down is extraordinarily fragile. It can end in a generation. What the record cannot show is what else existed. Bronze was recycled, systematically. The Roman world melted Greek bronzes for coinage and weapons on an industrial scale. The Antikythera mechanism survived because it was on a ship that sank before it could be melted in cold, oxygen-poor water that slowed corrosion enough to preserve its structure for 2,000 years. That is a specific and unlikely chain of events. Every other object like it, and the evidence of the mechanism itself argues that a workshop tradition capable of producing it must have existed, is almost certainly gone. The question the evidence genuinely cannot answer is, how extensive was that tradition? Was the Antikythera mechanism one of a dozen similar devices? One of 100? Was there a lineage of makers at Rhodes who produced instruments like this for wealthy patrons over multiple generations? The mechanism does not tell us. The surviving textual record does not tell us. Cicero's description of a Posidonian orrery is tantalizing but imprecise. What would change the picture? Another mechanism, a second device, from any provenance, any date within the Hellenistic period, would tell us whether we are looking at an isolated achievement or a tradition. Underwater surveys of the Mediterranean are ongoing. The Antikythera wreck itself has not been fully excavated. A new survey authorized in 2014 found additional fragments still on the seabed. The possibility that a second mechanism or related device lies somewhere underwater is not speculative. It is a live research question. The Antikythera limit is not the claim that the ancient world was secretly advanced. It is the recognition that our picture of what the ancient world could do is built almost entirely from what happened to survive. And survival in antiquity was heavily biased toward stone, toward writing, toward things that were too large or too sacred to melt. Precision bronze instruments were none of those things. The mechanism exists. The gap exists. The explanation for both, a brilliant but fragile workshop tradition that made one surviving object and then vanished, is plausible and consistent with everything else we know about how knowledge moved and died in the ancient world. But plausible is not the same as complete. The record has a hole in it roughly 1,400 years wide. We know what was at one edge of that hole. We know what was at the other. What fills the middle, what was built and lost between the 1st century BC and the medieval clockmakers of Europe, is a question the evidence raises clearly and does not answer. The Antikythera Mechanism is the most important technological artifact from the ancient world. Its full implications for what the Greeks knew, what they built, and what was lost are still being worked out. If you want to follow questions like this one, subscribe to Hard Truth Science on YouTube. New episodes every week. Follow us on YouTube at Hard Truth Science.